Hello, welcome. Today we will be doing Unit 9 of Optical Phenomena, and we will be predicting whether light will be refracted or undergo total internal reflection by calculating the critical angle. We first get started by looking at our problem, and our problem states, find the critical angle for a water-air boundary if the index of refraction of water is 1.33. So from that, we have our givens, which is the index of refraction for the first medium is going to be the water, which is 1.33. And then we have the index of refraction of our second medium, which is air, and we know that that is 1.00. And we are solving for the critical angle. The equation that we use is given as the sine of the critical angle is equal to the index of refraction of the second medium over the index of refraction of the first medium. So by plugging in our numbers, we get 1.00 divided by 1.333, and we solve that the sine of theta is equal to 1.00 divided by 1.333 is equal to about 0.75. So by doing the inverse, we solve for the inverse of sine. We solve for the critical angle. We get that the critical angle is equal to about 48.6 degrees. So now that we have our critical angle, we will decide whether whether the light will be refracted or undergo total internal reflection. So for deciding that, we look at the definition of total internal reflection, which is it occurs when light moves along a path from a medium with a higher index of refraction to one with a lower index of refraction. So the first one that we go is water. So it is a 1.33 to a one with a lower index of 1.00 of the water, so therefore it's going from a higher index to a lower index, and therefore will undergo total internal reflection. There we have it. We have solved for that, and we predicted whether light will be reflected or undergo total internal reflection and calculated the critical angle.